Welcome everyone. Welcome to the last session of the day, of the first day of the festival. My name is Flo. I'm going to be chairing the session today. Is my sound okay? Can everybody hear me okay?
Yes.
Fantastic. We've got a very exciting hour ahead. We'll have two speakers. We'll start with Salma ElSayed, who's from Abertay University, who's doing a talk called Escape to Learning Using Puzzle-Based Entertainment. And after that, we'll have Victoria Wilson-Crane from Kaplan International Pathways, whose talk is entitled Kindness as a Pedagogical Superpower, Securing Student Outcomes in an AI-Driven World. It's very exciting. We'll have about 20 minutes for both sessions. Each session it will be 20 minutes. And we'll have some time for some questions and discussions after. The first thing I'll do is I'll post a link in the chat. That's the link to the festival Padlet. That link is where presenters can leave resources or anything they want to share, so people can find that later if they'd like to. The other thing I should mention is the session is being recorded. If you don't want to appear in the recording, please turn off your camera and you won't appear. Sessions are only 20 minutes, but like I said, we'll have some time for questions afterwards. So please save your questions for the end. There's also a chat function. I'll try to keep an eye on the chat. If you have anything you want to share, please put it in the chat and I'll keep an eye on it. I think that's all I have to say in terms of housekeeping. Salma, are you happy to start?
Yes, thank you very much.
Very good. I'll hand the floor over to you.
Thank you. I'll share my screen again then. If you let me know if you can see that.
We can see your slides.
Okay, excellent. Well, good afternoon, everyone. Thank you very much for joining me today. So we're going to explore how puzzles can unlock deeper engagement and critical thinking in our classrooms. You will try to find some hidden phrase to escape, just like my students did. I'll explain this in a minute. So, yeah. Just to start with, who's been to an escape room recently or ever? You can just pop your answer in the chat. Did you learn something? What did you like about it? What you didn't like about it? I don't know if I can see. Yeah, I can see the chat. Yeah. Too scared. That's the frustration. Okay, and lots of learning. Absolutely, I agree completely. I like that a lot because frustration and learning, I think they go in hand. I'll explain that in a little bit. Collaboration, absolutely right. Excellent. So at least we agree that it requires some sort of cognitive load. Oh, the screen's on. Okay. So the idea behind puzzle-based learning is to challenge the student, to stimulate logical reasoning, problem solving. It's not just about games and fun. As I mentioned, it's a cognitive struggle, which is not necessarily a bad thing. It could be utilized in a meaningful way. And the idea is for the student to solve puzzles to escape, and this adds challenges and builds towards, adds the challenge for them to build towards a certain goal. So they try to cover a lot of material, for example, and it's a layered way of problem solving. So I used this in one of my introduction to machine learning modules. So I embedded riddles and clues across the material. Some were through MCQs, some were through lab materials where the student had to tweak some exercises. Some were using riddles, logic-based brain teasers, stuff like that. So this spanned 10 weeks. The students collected letters through the weeks, and in the end, they had to unscramble them to reveal a key concept relevant to machine learning and escape the module. This was not a graded exercise, just to add an engagement factor to the module. The idea is that I always observe students ignoring lectures and readings, particularly when the coursework is the main assessment. So this approach was intending to engage them across all the weekly material, not just focusing on the practical side of things. It also gave them a chance to practice more problem solving, critical thinking across different sources, and making learning active and fun, hopefully. Which basically mirrors what the real world problem solving is all about, the authentic assessment and the demands of the actual problem solving in this particular field. So today I'm will attempt to guide you through a similar simplified experience. Probably will run out of time, so maybe I'll bear with me if I'm going too quickly. So you are trapped in this slide deck and you should uncover a hidden phrase to escape. So clues are embedded across the slides, and given material, I'll give you all material you need. And each clue should reveal a letter or a concept. I will present a fundamental concept in machine learning. As you go through the material and the activities, try to figure out what the clues are about, collect the letters, and your ultimate goal is to uncover a key element in machine learning. So these are more instructions. So I would recommend, if you have paper and pen or any digital equipment aside, feel free to look things up if you want to. If you want to use your favorite language model, search engine, absolutely fine. If you want to take screenshots of the slides, if necessary, absolutely okay. I'll share with you in the chat a link to a Google document. Just let me know if you're able to access that. It has some material that you might need. Some slides will have timers, just for me to keep things right, because I know I'm probably will run out of time, but anyway. So try to look for clues. So that's what I did with my students. In the areas of the material that I wanted them to extract a letter from, I added a clue or an icon, for example, a magnifying glass, something that a puzzly, themed clue, a magnifying glass, a lock, a key, something like that. So any questions before we start? Anyone having trouble with the Google document? All good?
It looks like there's 20 people in the document, so I think everybody got in.
Okay, I can't see the document now, so that's okay. Okay, so let's begin. So the topic we're not moving. Okay, so today's topic is how data and algorithms shape our lives. So algorithms are step-by-step rules, like recipes, for solving problems. And the term comes from scientist Muhammad ibn Musa al-Khwarizmi. So that's a Persian scholar who works in algebra. And his foundation work was essential for modern computations, the first systematic solution to linear and quadratic equations. And the name Khwarizm algorithm came from his name. So we all interact with algorithms on a daily basis, social media, GPS, shopping, online, in-store recommendations, all of these things. And while my modules focus on machine learning fundamentals, including technical bits, I'll start with a non-technical aspect of things because I wanted this to be accessible to all disciplines. But first, before we talk about algorithms and data, what is machine learning, which is the engine behind the algorithms we want to address? So artificial intelligence and machine learning are used usually interchangeably these days, but it's not necessarily correctly because machine learning is a sub-branch of AI, but that's for another day. In simple terms, machine learning is about teaching computers to learn from data. So data is the experience, the algorithms are the instructions. So it's like giving the algorithm information or giving the algorithm experience to learn from to be able to make decisions. So they look for patterns from existing data to be able to predict on new data. This is important because machine learning now is influential in personal areas, like, for example, social media feeds, credit scores, even medical diagnosis. Ideally, I would use polling technology, but again, because I think we're short on time, I'm just going to rely on PowerPoint from the MCQs. I will give you maybe a few seconds to read them, and I'll try to time them on my own for the sake of finishing on time. Okay, so this is our first activity, a quiz. So what determines your Instagram feed? Is it your luck, your feed, your Facebook feed, your previous Instagram selection, or your ex? All of the above, I like that. Yeah, absolutely excellent. Thank you very much. So indeed, previous selections, the history of what you did before, sometimes the history of other platforms that are linked, but mainly, yes, your previous selection is the main component. Here's another one. Think about what we just discussed so far. What do you think is the absolutely necessary component of machine learning algorithm to be able to learn something useful? Is it relevant and sufficient data, hardware, complex algorithms, or skilled program? Yes, so everybody's saying A, absolutely right. A is correct. So indeed, relevant and sufficient data. So this establishes our first key point. Data is the fuel. Without data, even the smartest algorithms are useless. If you notice here, the first clue or the first piece of the puzzle is the letter A. This is me just explaining because that's the first time we come across this. If you notice at the top of the activity, there is a clue in the word quiz. So there is a magnifying glass instead of the Q, and then the A has that as well. So that tells the student that the letter of choice is part of the puzzle they were going to use in the end. So we collect the letter A. It's the same idea across the other slides. What's it called? Some clues are paired, so you need different slides to connect to the clues, and they should match. The clues would match in style, color, and hints, and all of these things. So just keep an eye for that. Okay, so in today's world, data is the new oil, the new currency. It's incredibly valuable. It comes in all shapes and sizes, but mainly machine learning algorithms require data to be in numeric format. So images, text, videos are often transformed into numbers. And the estimation is that by 2025, did I jump? Yeah, by 2025, around 180 zettabytes of data will be generated, and that's like mind-blowing, which requires algorithms to be more powerful because automation is just going to be mainstream. So most algorithms work with numbers, and so we often convert data into a numeric format. So for example, the word red would be number 1, the word apple would be number 2, images would be matrices of numbers, and all of these things. So it's crucial to explore the data before you feed it to a machine learning algorithm. And one of the key things to do is to visualize the data, to have a look at the data as a data scientist or even a researcher. And some of the things you can do is to plot the histograms of the data. So for example, here we've got 2 histograms. On the right side is a simple bar chart showing the number of loans approved by 2 groups. Group A has significantly more approval despite being in the same circumstances or the same application. On the left side is a histogram of abalone distribution. So that's a standard data set in machine learning. It has information about abalone in terms of the species, the sex, the dimensions, the weight of the abalone. So here we're plotting how many observations are for each sex, so male, female, and infant. You can see that the classes are relatively the same size, but not necessarily exactly the same. It's also important to examine the data further. Let's look at the features, for example. Are there any features in the data that are more correlated than others? So one example is to generate a heat map or a correlation map. So strong correlations shown with higher colors or warmer colors or higher numbers, and weaker correlations are shown with smaller numbers or darker colors. So if you look at this correlation matrix, maybe take a few seconds to try to see, can you spot any features that have little correlation, any features that have noticeably stronger correlations, because that could be something that we'll use later on. Okay, so how can these features be useful? So think of the simplest thing you can do on your phone, scrolling. Tons of information can be extracted from just the single swipe. So algorithms need to know about your clicks, page reviews, search queries, products preferences, and all of these things to be able to personalize the outcome or provide certain ads for you. Some sensitive information is also collected, but again, this has to be with the consent of the user and should not be used for training purposes. So here comes out of nowhere your first riddle-based piece. So I'll give you maybe 30 seconds to read this riddle and try to think of which part of the material you've seen so far is relevant to this, which slide, which graph, which MCQ maybe. I'll just have the timer for 30 seconds. You can read the riddle and try to maybe figure out if it means anything to you based on what you've learned so far, or what you've seen so far. Right. So if you remember from the abalone histogram slide, the slide had title Observe. as an activity and had the clue with the, what's it called? The lock. So if you go back to this slide, you'll find the same two clues, observe and the lock. And you can use this riddle with this histogram to come up with the answer. So it's asking about a histogram of shells. So that's about histogram of abalones, as about the count. It's asking about the class that's neither ahead nor behind, but in terms of count, not in terms of the position on the histogram. So the class that has the number of observations that in between the two classes is the class I, the infant. So we've got more observations from male, fewest observations for female, and the infant is in between. So that means the students extract the letter I. This clue was also available in your lab sheet, which is the Google document, just to give you an idea of what the students had to do, because the riddles and the clues were spread across different sources. Okay, so what do algorithms do? They do predictions. There are two main types of predictions: regression, which basically predicts a number like the temperature or the age or the cost of a house, and classification, which predicts a category, like, for example, the person matching on a face or fingerprint, or categorize an email as spam or not spam. So our next question, let's say that we're teaching a computer to recognize different types of fruit. So what would be the best way to provide the learning material, which is the data, to the algorithm? Is it just giving it the names of the fruits in alphabetical order, pictures of fruits with their names, taste of the fruits in abstract words, or the chemical composition of each fruit? What would be the best type of data? B, absolutely. Everybody's saying B, absolutely, right? Good. So giving the algorithm a lot of pictures of different fruits with the labels would mean that the algorithm would make association between the picture and the label, such that it can tell them apart when it's introduced to new information about, or new pictures of fruit. So again, because this has a clue at the side of the slide, the student is expected to extract the letter B. An interesting type of data that's collected from users is mouse movement, gaze on the screen. So this is an example of an eye tracking output to assess where the user is looking on the screen. And usually the case that advertisement or common products are placed on these locations on the screen. We've got a clue again coming up in this slide. And again, I'll give you maybe 30 seconds to read the clue and try to decide which part of the material this is relevant to, or which slide maybe. Which example? Right. Again, this clue was available in the beginning. So if you had the Google Sheet as your lab sheet, you probably would have the clue from the beginning before the lectures. So this links to the correlation matrix because it talks about flames, talks about colors, where 7 and 8 are less than 1, because here we have 0.7 and 0.8. It talks about the shape that will help you cross to the other side. So this is a visual clue. So the students are expected to look at the visual shape of the correlation between the features. So they extract the letter T. Okay, so we've talked about the importance of data. What if we don't have enough data? Because usually real world problems don't have or don't provide us with enough data. Data is incomplete, messy. We've got, for example, deleted data. We have a saying in machine learning, garbage in, garbage out. So if you feed the algorithm bad data, poor quality data, you get bad predictions. One key issue is unbalanced data. So some classes or some data groups can be overrepresented, leading to inaccuracies in predictions. So I've got another situation here where the AI, so we have an AI hiring tool that is preferring male candidates over equally qualified female candidates. What would be possible reasons for this outcome? Why would the machine learning algorithm be doing this? Is it unbalanced training data, the programmer's assumption, historic inequalities, or insufficient data, or everything? Absolutely. It's all of the above. They happen in combination. They happen at different stages in the data processing or the machine learning pipeline itself. But yes, all of the above is correct. Again, you can see here that there is a clue of a puzzle piece, which means that the students are expected to extract a letter from this activity, but there are no letters in the output of the choices. So they have to think of how to, what's it called? Transform that option to letter, which is S. So the shape of 5 is resembling an S, so S is one of the pieces of the puzzle. And the last activity to do is the appraisal activity. So I'll ask you to go to your lab sheet, which is a Google document. There is a task there to complete. There's a light reading bit to do, and then you have to ask a language model to do something for you. So if you're able to do this, that would be great. Oh, sorry, I'm running out of time. Okay.
We can do this activity if we've got a minute. That's fine.
Yeah, that's the last one we're doing. Yeah. Yeah, so I'll give you maybe 30, maybe 40 seconds to do this. If you are able to go to the Google document and do that, that would be great. So that will be the activity in the second page. So activity appraise. So you can skip the riddles. We're done with the riddles. You can just jump to the appraise activity. Are you able to maybe pop in the chat whatever concepts you thought about, whatever descriptions, one-word descriptions you can think about or got from a large language model? Just leave them in the chat and have a look at them later on. Okay. So far, if you've done all of discriminatory bias, religious bias, discriminatory, excellent. So if you collected all the letters and you've done the activity of the praise, discuss this with the language model or discuss it with your classmate or the staff, you should be able to have these letters A, I, B, S, and the concepts the large language model suggested. And if you unscramble those, and based on the material covered in the slides, talk about algorithms and data, and any problems in the data will cause the algorithm to be biased. So our escape key for today is bias, which is a crucial factor in machine learning. As I mentioned in the beginning, I use this for algorithms to I use this for the students to in an attempt for them to engage more. Did my learners engage more? Not necessarily. I think because this is not graded, it didn't necessarily. It wasn't necessarily motivation. It wasn't necessarily motivating for them, and I think it probably needed to be more embedded into the material itself. Well, thanks everybody. That's me for today. Thanks for playing and for being active on the chat. Let's keep rethinking engagement one puzzle at a time. Yes, absolutely. There's a W, there's a T, and there, yeah, absolutely right. A couple of letters that are not part of it, because I can quickly go back to show you that they didn't have clues. So that there is a T, but it doesn't have a clue. And the clue actually is, I think, for the W, there is no clue as well here. So yeah, you can collect several letters, but they're just red herrings, falsies. They're not, yeah, not part of the word. Thank you, everyone.
Thank you very much. That was very lovely. I don't think I've ever looked this closely at slides trying to look for clues. Very nice to have an interactive thing. It's 25 past, so we have time for maybe 1 or 2 quick questions before we move on. Is there anybody who'd like to ask a question? People can either unmute themselves or put a question in the chat if you have one. It's very clear that it spoke to a lot of people. There's quite a lot of chat going on in the chat, so people were clearly engaged by your slides and the game.
That's good.
Right. I don't think there's any questions at this point, so we're going to move on to the next.
Stop sharing my screen.
Yes.
Thank you.
Thank you again. Yeah, that was very lovely. We're going to move on straight with the second part.